Hello everybody, welcome again. Today we will talk about a new feature that we will add on to the RS communication between Raspberry Pi Pico and the Arduino. So we will work on the first feature that we set as a future work in the previous video, if you remember, in the part 3 of the design and implementation of Arduino multi-hop RS Modbus network. So let's see what we were talking about. Okay, future work. So for sure, as we said just now, we won't stop up to here, but we have a future works to do. Maybe you guys, you can try to do it if you can, and we can share our code, we can share our knowledge to see how to do this. This one is just my future plan. But I haven't have a clear idea how to do it, but this is what we can do. First of all, we can add a timeout. If you remember, until now, all our requests, if the request is not being answered for any reason, okay, if you go back, if let's say the base station send requests to any of these nodes, and for some reason, for example, node 1 is powered down, or maybe send requests for some node that not exist in the network, let's say number 10, the base station will keep waiting, okay, will be waiting forever. So why not we add a timer, okay, to time out our requests. For example, we send a request, then we wait, let's say, for a few seconds, maybe 5 seconds. If there is no response, then we can declare, okay, it's a timeout. So either the node is down or the node does not exist in the network. Okay, this one is the first thing we can do, and I believe this is not that hard to add a timeout to our current address scheme. Okay, guys, so we have seen the first feature that we were talking about previously, which we set as a future work, is to add a timeout to our request. If we request, then there will be a timeout. If more than this timeout we got no response, then we will declare the command being timeout and we throw an error to the user. Okay, so this is the title of our new video. Not only that, but we will talk about very interesting things of Raspberry Pi Pico, which is the threads. We will use threads to separate these or to enhance our RS communication. We will use 2 threads, one for the process and sending command, another one is to receive and process again display. So these 2 threads will be used separately and concurrently to send and receive the requests and comments between the nodes, or between the master and the other slave nodes. Okay, guys, let's do it. Now, guys, we will start from here. So this is the master code, the Pico master code that we'll develop in the previous tutorial. Okay, so this is the one where we send data 1. We assume that we are sending data 1, then we read data 1. This one, where is it? This one, read data 2. So this code we've been developed already in the previous code, previous tutorial. Sorry, if you haven't go through yet, I advise you really to go and watch the series from the beginning to have the complete picture of what we are doing. Okay, so this is the code from the previous tutorial. Let's give it a go. So if I run, I already connect the Pico or the master to the node number 1, which is Arduino Uno. So now if I send number 1, here we go. So send data 1 done, and reply 2 from the Uno 2. Now here we go, done 3 from the Uno 1. So what we will do, as we said previously, the first thing we'll do is to use threads here. So this main loop, or not this one actually, here, start from here. This code is responsible for sending the request to the node, from the master to the node. And the rest of the code from here and to here, this is responsible for detect whether there is a received data from the node and decode it, analyze it, then display it, etc. So we will work on the thread. So this will be thread and this one will be thread. And also we will work on the timeout. Okay, so if now, let's say I will disconnect the connection between the node and the master. So now if I send one, you see, the master is sending data, but for now we don't know what's happened in between. For sure, we know I already disconnect the connection, but if you have a big network, you don't know what's wrong. Then you keep waiting for nothing, but actually maybe the connection is down, or there is a cutting in the wire. Okay, so we will time out this request. Again, if I send another request, sorry, this is wrong. Let me reset because this one wrong. Oh, I guess it's keep waiting, because as long as we send the command, okay, in this while loop, and there is no response, it will be continuously looping here, doing nothing, just waiting for the response from the node or from the owner. So I reset already. I will reconnect. There we go. I reconnect again the connection to the node. So if I send, oh sorry, I need to run the code first. Please try again. Okay, sorry. Do I need to restart? Okay, I restart my Pico. Here we go. Let's run. There we go. Okay, something happened previously. So if I send one, here we go. Send the data and I got response. Send data, I got response, because now I already reconnect the link. Okay, so we work on these two things. Okay, guys, so we can see here, this is the code from the previous video where we learned how to perform the threads and how easy it was to be done. So now I will try, and here is the code that we developed in the latest RS tutorial, RS what they call RS based on the Pico as a master. So this is our R by Pico will act as a master. So this is the code, the normal what we call round robin loop without any threads. So today we will convert this code into a threads. Okay, so I will make a copy of this, Control A, copy, and make a new one. Here we go. Then I will save it in my Pico as a RS master with threads. .py. Okay, cool. So now let's see how to improve this code and make it as a threads. We make it like two threads. We see here we have two loops. We have one loop here. This is to send data from the master to the network or to the nodes. And another loop is here while command send. Another loop is here. This is the one that will keep listening if there's any incoming data from the rest of the network or from the rest of the nodes. Okay, so what we need to do is first let's declare a new function. We take this and I will cut it, and I will declare another function here. I will call it define rs underscore receive underscore thread. Okay, so here is my thread, then pass. Okay, so this is the thread that will be responsible for receiving the data from the rest of the nodes, and this is the one that's responsible to send. So the one who is responsible to send, we just keep it. We don't need to do any changing on it. So most of the changes will be on the second thread. And again, here's we will change this one into a while loop. So here we need to have a while loop. So while true, so we'll be continuously running, while true. And do we need to have a command send? Yeah, I guess is it good to have this. Otherwise, we'll keep looping. Let's try. We maintain this while true, while command send. So here I need to add a sleeping time. Same like here, so we give a time to the CPU to take a breath. So while true, we put it here. Yep, under this loop. Okay, cool. While true, while loop. But one more thing, since we have the the command send has been updated somewhere else, so it's better to assign it as a global. So where is the function? So here we need to define global command send. Okay, so it was mean global, so it's been taking the data will be read from the other function, so it won't be generating new variable in the domain of this function. This is important. Okay, I believe that's it. Oh no, sorry. We need to add the threads package itself. So I need to import underscore thread. And what else? And we need to declare our thread maybe here. So I will declare my thread dot start underscore new underscore thread. So the name of the thread will be this. And I don't want to pass any this parameter. I believe that's it. Let's run it. Here we go. Doesn't match any routes indentation. Which one? Why? Got indentation issue. This one correct. This one correct. Is it this is the one? No, it's line 33. So if I bring this one here, bring it back, then that's correct. Maybe it's something regarding to this guy here. So I'll take like 1. So now it's under this domain. Now I bring it here. Now should be okay, hopefully. No. USB timing call back. It doesn't. Oh, this is the USB issue. Let me try to close. Oh, now I need to disconnect and connect again. This is the thing. Okay. Restart. Should be happy now and run again. There we go. So now if I send one, hopefully I get response. Yes, done. If I send 2, response. Yes, done. There we go. It's working as a thread. So here it is. So if you see, guys, here we already changed our code into a thread. Cool. You see how easy it is? So now I have this thread, this one, running continuously, waiting for data from the USB. Okay, then it will be decoded. Then based on the decoded number, then we send the data to the nodes. And the other function, it will be running at the same time, okay, listening of any income package from the, or any response packet from the networks or from the nodes. Here we go. So it's running, is functioning as expected. So if I send once, and there we go. Sometimes we got this issue that I guess is a known issue because of the USB. Thread with the USB got some conflicts. So I need to again connect and disconnect the Raspberry Pi Pico. So I guess we need to add what they call a try exception at the main loop. So if I'll try to add a try here. Okay, so when it's decoded data, so this one all will be trying to this. If anything wrong with the decoded data from the USB, then except I need to just continue. Okay, that's it. So just continue. Let's try again. Let's see if we can face the issue again. There we go. Let's see if we stop it for sure. Okay, cool. Now run again. Here we go. So now we can see hopefully the issue being solved, that the one related to the USB or tiny USB conflict thingy. Yeah, you see now we got it again, but this one's okay because we already killed the code. Okay, so now I need to disconnect. That's why I connected again. Boom, here we go. So now if I reset, should go back again, and yeah, here we go. So now we won't see the tiny USB issue. It just maybe it might be happen after we kill the thread. You see now I'm killing it. It looks okay. It's accepted without any issue. But sometimes when I kill it, sometimes happen, but it's out of our control if after we kill it. But if during the execution there might be an issue that we need to solve. But yeah, we might need to add this exception to our code. Okay, guys. So now we have done with the thread. So let's continue and do the timeout feature into the code. So now let's say we see now I send one, it's already got the response. I'll try to disconnect the cable. Here we go. I disconnect the cable. So now if I send data, you see it sent the request but got no feedback. Just the master keep waiting, hoping there will be a response from the node, but actually there will be no response. Okay. So if I send again, here we go, send but no response. Okay, I connect back again, send one, here we go, response back again. So that's why we try to time out this condition where we send, but for some reason the connection might be broken, or for any other reason, or the node is missing, or there's no node with that, for example, address on the network. We need to time out that one. Okay, let's do it. Okay, good. So now we will talk about the timeout of the command or of the request. So most of the changes, or all of the changes, will be in the thread where we will receive, or we expect to receive, the command. So what we will do is just simply time out the response. Once we send the command, or command we confirm is sent, we start to time out or calculate the time, the duration, or the elapsed time. If it's more, let's say 5 seconds, then we will throw the timeout error. So what we need after the while true, we need to find the what we call the previous second equal to time. Since time we already declare it up here, so we will use the same package to return us the second, since we are in the second domain. Time.time. Okay, but this one will return, if I'm not mistaken, is a milli or microsecond, so we need to convert it into a seconds. I'm not quite sure about this. Anyway, and we need the elapsed second. Make it 0. Okay, that's good. And here the command, not only we will not have a condition of the command send, but the elapsed time should be elapsed second, sorry, should be, let's say, less than the timeout, let's say 5 seconds. And this, so we have two conditions. If the elapsed second should be less than 5 seconds, if more than 5 seconds, for sure we need to go and, let's say, somewhere here, we say if the elapsed second is more than 5, then need to print timeout error. Okay, so here we check if elapsed second is, let's say, equal 5. I don't want to be more than 5 because later I might have an issue. If it's directly equal to 5, then I will print what? We will print error timeout, no reply. Okay, and what else? We need to reset or release the command send. So the command send. So the command send will be equal to false, because after 5 seconds I don't expect and I don't need any response. I consider this one is a non-valid response if I got the response after 5 seconds. Okay, so should be less than 5 seconds. If equal to 5 seconds, I just throw a timeout already. What else we need to add? So after here, after the condition, we will take the current second. So the current second equal to same. We take this guy here, time of the time, then the elapsed second. We calculate the elapsed second equal to bracket. Here we need to convert it into a seconds. We convert the current and the previous second into a second, because again they are into milliseconds if I'm not mistaken. So we have the current seconds convert into seconds minus the previous seconds, again integer of previous seconds, convert to seconds. Here we go. Then we will find the elapsed second, then we go through. If we go through and we can't find any reply within that time, then we will throw this error. If we got a reply, let's say we got a reply, let's see here, for sure we will reply somewhere here. If already got a reply, then we need to clear the elapsed second. Also not clear, because if clear we still less than 5 seconds, we just put any value more than the timeout, which is, let's say, 10 seconds. So 10 seconds will not be here anymore. It will break this while condition, then it will go to the main while where it's already cleared the elapsed second, and the comm send also will be cleared here. So both of the condition will be false, so it won't enter here anymore. Okay, so I believe that's it. Let's give it a try. Let's give it a try. Okay, saving, here we go. Our master app are running. Let's send 1, for sure expect a response now because already connected, and 2 is already connected, should be response. Here we go. So now I will disconnect. Here we go. I disconnect the cable. Now I send. Now we will need to count 1, 2, 3, 4, 5. Here we go. We got the timeout. So cool. There's something in the network. No need to wait anymore. I send again 2. Okay, 1, 2, 3, 4, 5, Boom. Here we go. It's a timeout. Now I connect again. 1. Should go to response. Boom, boom. That's cool. That's cool. So now I disconnect again. One more time. 1. I should get timeout within 5 seconds. Beautiful, beautiful. Very good, guys. Very good. I'm very happy with the results. So again, we need this variable, which is the previous second and the elapsed second, to be included after the main while loop for the second thread. Then we add the condition of the elapsed second should be less than 5 seconds. Then we keep monitoring the current second, and we calculate the delta of the previous and the current, which we name it as an elapsed second. If this elapsed second is more than 5, then we just throw the what they call the timeout error. If no, we got error within the 5 seconds, we just set any high number, so we broke the loop to clear the estimate second or elapsed second at the main loop. Here we go, guys. So that's good. It's a good improvement. So we have done with the first feature where we had the timeout. Okay, so here we go. We have the timeout feature already implemented. At the same time, we use the threads now. We don't depend on a single round robin method. Okay, so we have 2 threads running concurrently at the same time. Keep one thread sending data, another thread receiving the data, and that's good. Good, that's good. So we have reached to the end of our tutorial. I hope you have learned a lot from this this implementation of this feature. And yeah, please do let me know if you have any questions or anything you want to discuss. Do comment down below in the comment sections. Thanks, guys. See you soon in the new videos. Bye.